Hello, children. In the last few videos, we understood what is the Newton laws of motion and problems how to solve based on the Newton laws of motion. Now, in that Newton laws of motion, one of the topic we're going to consider, that is apparent weight. Okay, problems based on the apparent weight we're going to solve. Before understanding the problems based on apparent weight, first we're going to understand some of the theory regarding it. Let us see the theory. Apparent weight of a man inside a lift. When a man is there inside a lift, when the lift is at rest position, no children, so his weight is just balanced by the normal reaction. So just what is, suppose any block is there on a rest position, what are the forces acting, and this one will be the weight, that is mass into gravity acting downward direction. And the same time, to balance this weight according to Newton 30, there must be another force, right? That is a normal reaction which will be balances the weight, then only we can able to stand. Suppose imagine if there is no normal force, we cannot able to stand. That's why in case of interstellar space and that, we cannot able to stand. There is no normal force there. That's why we just float at the surface, okay, in the air. Whatever, leave it that. Now let us understand this theory. Apparent weight of a man in a lift is when a man of mass m is sitting or standing in a weighing machine. Standing on the weighing machine, where the weighing machine, this is a weighing machine. It is placed inside a lift, okay? It is placed in a lift. The two forces acting on the man are his weight, W is equals to mg, downward direction, children, this is downwards, and the normal reaction which is acting upward direction, okay? Then when the lift is at rest, okay, see when the lift is at rest, no, both will be balances each other. So his, what is get, when apparent weight will be the 0. When the lift is at rest position, what will happen? Mg, both will be equal. Mg is equals to normal reaction. So that what will get, you will get apparent weight will be 0. So R normal is equals to mg, Rw, we can write mg is nothing but weight. Our apparent weight is equals to just his weight only. Understood, children? Apparent weight is equals to his weight. What is weight outside, same weight will be shown here also. When the same lift is moving upward direction, imagine children, the same lift is moving upward direction, then the weighing machine, what it will show, the apparent weight in the weighing machine will be just shows increasing. So why it is increasing means, you also experience when you are traveling in a lift, when the lift is going upward direction, no, it need to go against the gravity. So here acceleration will be what, children? Here change in acceleration is gravity plus acceleration. What acceleration lift is moving plus gravity. So it both forces it need to pull, right? So that's why the weight is appears to increase. So children, when the lift is moving upward direction with an acceleration a, in that condition we can write normal minus a weight, that is nothing but how much the difference of force, you know, net. According to Newton's second law, we can write no, net force is equals to, or sum of the algebraic sum of all the forces is equals to a mass into acceleration. Right, that is only we wrote here. Net force here it is mg is downwards, n is upwards, n is more. That's why body is moving upward means n is more. So n minus of mg is equals to ma. So this Newton's second law we applied and wrote. And n is equals to mg. This left hand side you can take this side. What will happen? Mg plus a ma. Understood, children? Or you can take m as a common. We can write this just g plus a also. When normal reaction, when the body is moving upward direction, given by m into g plus a. Okay. When the same lift is coming downward direction, children, when the lift is coming downward, so compared to normal reaction, weight will be, this acting weight pulling downwards is be more. So that first we can write here mg minus of n is equals to ma. Here which force is more, no, difference of force we're going to take, which force is more, that we're going to take first, and next we're going to take remaining. So your weight is more, so that body is coming down, mg minus of n equals to m into a, or n equals to mg minus ma, or we can also write m into j minus a. When a lift is coming downward direction, your weight is appears to decrease, and weighing machine what we kept inside, no, that will also show less reading. Suppose here your mass is exactly 60 kg. When it is going upward direction, your mass it will show in the weighing machine as 70. When same weighing machine is there inside, it will coming, when the lift is coming downward direction, that time the weighing machine shows only the 50 kg. That means appears compared to normal weight, it appears to decrease. Understood, children? Next, when a lift moves down with an acceleration g, freely falling. That means just suppose imagine some thread is suspended with some support. Suppose the suspension is break, what will happen? It will just fall freely. When it is falling freely, in that condition, what will happen, children? The normal reaction will be zero and weight, apparent weight, what is the weight appears? No? You feel that weightlessness, what we call, no? That condition has weightlessness. So when the freely falling body does not feel any weight, that is called condition called weightlessness. That is why in case of planets, okay, in case of interstellar spaces, when they are rotating, okay, when they're out of station, there is no gravity. That time you will feel weightlessness, or you cannot take any support, and you can able to stand, or you can able to float. That is because of weightlessness. Okay. Here the man will leave the floor and the move upward. Feel his head touches the roof. Okay, you'll feel this just is imagine to move upward direction. When the lift moves up or down with a uniform velocity, it is going with a uniform velocity, condition that it will come like a normal reaction only. So when it is at a rest or it is moves with a uniform velocity, both the condition weight will be is equals to just normal reaction, that is nothing but m into g. When it is uniform motion or normal rest, and when it is going upward direction, it will be odd. When it is coming downward, it will be negative. Okay, children, you can remember all these formulas regarding apparent weight. Understood now? Apparent weight. Yes, children, any doubt in apparent weight? Okay. So let us recall. Once again, just revise what we learned. When the lift is at rest or lift is at moving with uniform motion, your weight is nothing but mg, that will be balanced. That will be is equals to apparent weight, or that is nothing but what we call normal reaction. Okay, children. And when the lift is moving upward direction, okay, when it is lift moving upward direction, apparent weight appears to be increases. Weight appears to increase. Children, that how many times you can write? Just write m into g plus a times it will going to increase apparent weight. Okay, that is what we call normal reaction also. N is equals to, we can write m into g plus a. Similarly, when the lift is coming downward direction, in that condition, normal reaction will be m into g minus of a. For the freely falling body, okay, body is falling freely without any other force, only gravity it is falling. Okay, imagine the thread support this connected with some support. It is some this rope is break. What will happen? It will just fall freely. In that condition, the normal gravity will be zero. No, just we can get normal reaction is completely zero. You will get. Understood, children? The weight will be exactly zero. You will feel that weightlessness when for freely falling bodies. Understood this all the points? Okay, with this understanding, let us pass on to next slide regarding problems. See here, some questions are given. A lift moving up with a uniform velocity. Apparent weight of the man in the lift is what, children? It will be is equals to its true weight. Understood? No, uniform velocity, or when they are at a rest position, apparent weight will be is equals to their true weight. That is what normal reaction is just nothing but W, that is m into g, that's all. Okay, I understand theory, we can easily answer that. Type this question, option C. Next. Apparent weight of a freely falling body. What will happen, children? Apparent weight of a freely falling body or normal reaction of a freely falling body is completely zero. Understood? Yes, these two questions done. Next. Yeah, let us see next question. A lift moving up comes to rest. It is moving upward direction. It will come to rest with a retardation. Then weight of the man in it is. Okay. See the third question, children. What is given third question? Okay. When a lift is moving upwards, okay, when the lift is going in the upward direction, some lift is there, it is going upwards, and it will come to rest. So what will happen? Its velocity just is come to rest, and with a retardation, okay, slowly it is decreasing and coming to rest. Then weight of the man in the lift, what happen? It will be remain same. Okay, so when it is come to rest, children, when it is at a rest position, apparent weight will be equals to its true weight only. So it will remains same only. Okay, it never increases or decreases. Okay, next question. See, next question is, a man weighing 100 kg is standing in a platform of a stationary lift. Platform of a stationary lift is, okay. The apparent weight of a man when lift moves up with an acceleration is given. Okay, try to solve this question, children. Very interesting. So use the formula apparent weight or normal reaction is equals to, when it is going upward direction, given by mass into G plus of A, and that's all, children. So mass is given as how much? 100 kgs into G value they told imagine as a 10, and acceleration is 4. I hope this is clear, right? So 10 plus 4, 14 into 100. So 14 into 100, how much, children? Yeah. So one thing here, one more thing you need to remember, how much you'll get. Actually, we got answer as 1400. Okay, 1400 newtons. But answer is there in kg weight. This 140 is there, but answer is there in kg weight. So you know, a kg weight means 1 kg weight is equals to, children, actually 9.8 Newton. Okay, or it is in the problem given as 10, no? You can write 10 meter per second square, or we can write. So we can replace the 10 Newton by, okay, children, we can just reply right here clearly. We can replace the 10 Newton by 1 kg weight. We can replace this because that is the rule. Okay, 10 Newtons, we can write 140 into 10 Newtons. This 10 Newtons I can replace with 1 kg weight. This is a conversion for kg weight to Newton. So that option will be the B. Understood, children, why option is B? Instead of 1400 Newton, we can write in terms of kg weight, means 140 kg weight. Okay. Yes, I'll just clear the screen because I want for extra solving problems. Yes. Next question. Yeah, fifth question. See, a body of mass 1 kg suspended by a string. 1 kg is there, it is suspended by a string like this. Okay, in the thread of body, move with the uniform acceleration. Okay, how much acceleration it is moving? Acceleration is given as a 5 meters per second square, and gravity is this. So you need to calculate tension in the thread. What will be the tension in the thread? You need to calculate, children. So when the block is suspended like this, what will happen, children? The weight of the block is acting downward direction, right? And it is accelerating upward direction. Like in the case of a lift also, it is accelerating upward direction, no? So what will happen, children, when it is accelerating? The tension is nothing but the apparent weight. Here, when since it is moving upward direction, apparent weight we can write it as G plus of A. Understood, children? When it is moving upward direction, we can take apparent weight formula as M into G plus of A. Now substitute mass, how much given it is 1 kg, and gravity they assumed it as 10, plus acceleration is 5. So 10 plus 5, 15. 1 into 15, what you will get, children, answer? It is just 15 newtons. Understood? So it is option C. Okay, children, I hope this is clear. So remember the formula, tension in the string when it is moving upward direction, we have to take it as mg plus of A. Yes? Okay. So the sixth question, a lamp hangs from a light card from the roof of the elevator. Okay, like the elevator is there, from the roof of the elevator, one lamp is hanging. It is descending. Okay, elevator, when the elevator is descending means what, children? It is the elevator is moving downward direction. Okay, it decelerates, that means decelerate means negative of acceleration, given as how much? 2.5 meters per second square before coming, okay, before coming to rest. If the tension in the string, tension in the string given as 25 Newton. Calculate the mass of the lamp. Here what you need to calculate, children? Mass of the lamp you need to calculate. So we know this formula, same formula you just apply here. Tension will be is equals to what, children? It will be is equals to mass into acceleration g minus of a. Why I wrote minus of a, children? Because it is coming downward direction. It is decelerating. The acceleration means plus. If they give deacceleration, you have to write minus of 2.5, meaning that it is decelerating. So that we can write tension is equals to mass into g minus into minus plus 2.5. Or else we just substitute all the values at a time. Just a second, children. Yes. Pen. Yes. See, tension in the string given as 25 newtons, right, children? Tension is given as 25, and mass we need to calculate. And see, g how much is given? It is 10. Minus deceleration is minus into minus plus 2.5. Okay, simplify this. So m is equals to 25 divided by this entire term will go down. So 10 plus 2, 12.5. Okay, 25 by 12.5 will come. So 25 is almost half of this, right? So 2 ones are 2s are. So answer will come still at 2 kgs. Understood, no? 12.5 2s are 25. So answer is B. This is, if we cancel the ones are, this is 2s are. So mass you will get how much, children? It is 2 kgs. Understood, no? So formula, what you need to remember? Tension, it is coming downwards, m into g minus a, but instead of acceleration they are given deacceleration, so I have to write a as minus. I hope this is clear, children. Yes. See the next question. This second, just clear all the stuff. Sir, where are you? Yes. Now, see the last 7th question. A man inside a lift moving up with g by a acceleration has apparent weight is w1. Okay, when the man moves with his acceleration, his apparent weight will come as w1. The same man inside the lift moving down with an acceleration of g by 2. When it left, the apparent weight will be w2. You need to find the ratio of apparent weight w1 minus the ratio of w1 and w2. You need to calculate, children. Okay, let us write. See, I hope this page is not at all sufficient. I'll just take a new sheet to write this. Just a second. Okay, I'll just write here, children. Say, given data that when the lift is going upward direction, the given acceleration is g by 2. The same body, when the lift is going, okay, we're given w1. Okay, this is w1, and the lift is coming downward direction. Given acceleration is again g by 2 only, with this acceleration going downward. Now apparent weight will be the w2. You need to find the ratio of this w1 by w2 is how much you need to calculate. Alright, children, this is what the given data. Now you know when the lift is going upward direction, the formula is mass into g plus of a. Understood? The same lift is coming downward direction, that is w2, is given by mass into g minus of a. Right, children, this is what the data. But here when it is going upward, let us in place of a, what you need to take, children? In place of a, let us take it is a1 a2 only. Don't confuse a1 a2. When it is going upward, a given as g by 2, so just write down that m into g plus of g by 2. When it is coming downward direction, it is g minus of g by 2. Understood? Now you just simplify this, children, you will get the answer. Okay, what we need to find? We need to find the ratio of that. Okay, let us take w1 by w2. Since this by this we need to write, no, it will come this by this. So mass and mass get cancelled. So what is the remaining? LCM you take it as a 2. I'm taking LCM 2. So 2G plus of G, and down also take LCM 2. It will comes 2G minus of G. Right? So 2 again same they cancel. Up it is 3G and at the down it is 2G minus of G is just as is G. So again G is a common, it will going to cancel. So what you will get? 3/1. So ratio of W1 is to W2. Weight when it is going upward and downward with the same acceleration, then you will get a ratio is 3:1. Okay children, I hope this is clear to everyone. Okay. Yes, next question we'll see. 7th question, see children, then answer is option A. Understood no? By option A I solved so far. So this is option A, 7th one. Yes, next 8th question, see. Yeah. See 8th question children, what is given here? What would be the acceleration of the box as shown in the figure so that a block of mass m exert a force of how much force? mg/4 by the floor on the box. By the floor on the box. Okay. The floor, what will floor exerting on the box? What is the force we need to calculate? Understood? What is the acceleration? Okay, so sorry. The force they only given. Okay, you need to calculate what is the acceleration so that this much of force will come because of this acceleration. So what might be that acceleration? We need to calculate. Alright children? Okay. Let us see first here. Just a second. So apparent weight, wave force acting on the block, that is nothing but apparent weight. Right children? Apparent weight is given as what? mg/4. Apparent weight is given as mg/4. And since lift is accelerating and the exerted force, the block. Okay, let us take. Apparent weight is equals to m into g minus of a, because they shown direction here. What direction shown? Downwards. When the lift is coming, you have to take the formula g minus of a. Suppose if the shown direction is upward direction, you have to take g plus of a. And this apparent weight is g plus by 4, and here apparent weight is mg minus 4. Both left hand side is same, so that we are going to equate the right hand side. So that is mg/4 will be is equals to m into g minus of a. Now see m get cancelled both the sides. So g/4 is equals to g minus of a. Or send the 4 also that side. 4g minus of 4 into a. We need to calculate acceleration, right children? So send this g this side. So what will happen now? It will send like this. So 4a will come into left hand side and 4g here, the g will come to right hand side minus of g. So 4a is equals to 3g, or a is equals to 3/4 into g. Understood children? So here answer is C. Option C is the correct. What you need to do here is that you need to given apparent weight and formula apparent weight, both you just equate and you can able to solve for acceleration. I hope this is clear children. Okay. Let us see the next question children. Given a mass of 40 kg. This is the mass is given. Mass 40 kg is standing on a weighing machine kept on the floor of the elevator, which is moving with an acceleration of this. This is the acceleration they given, and the gravity is given, mass is given. For this is the given data. You need to calculate the reading of the weighing machine. So what the weighing machine will show reading, you need to calculate. Right children? So see here, lift is going upward direction. Right children, when the lift is going upward direction, apparent weight formula is given by m into g plus of a. Right children? So m is 40 kgs and acceleration G is and 2n acceleration is 2. So simplify this. 40 to 12 into 4. 12 4, so how much children it is? 48. Understood now children? 40 into 12 will come. So 12 4s are 48 and 0 is the right 0. This many times. This is apparent weight actually. But what you need to calculate? Only mass. So we can write W prime has mass into gravity is equals to 480 newtons actually. So we want only mass. We don't want G. G means what? 10. Right children? M into 480 by G. G means it is 10 we can write. So 10, 0, Markaya, what will get finally? M is equals to 48 kg. Understood children? When lift is going upward direction, the weighing machine shows it is 48 kgs. Weighing machine shows 48 kgs. Okay. Next question. When elevator is moving downwards within this acceleration, what is the weighing machine shows? Okay, when it is going downward direction, instead of plus G, you have to take the minus of G. I'll write here children, please see the weighing machine is M into G minus of A it will show. Okay children, so weight will be is equals to 40 into G minus of A is 2. So what will come? 40 into 8 will come. Weighing machine. Or we can write weight is nothing but M into G, that is 40 into 8. Okay, G we can take it as a 10. Send the digit side by 10. So 10 get cancelled. So 4 8. So how much children? Okay, second question. 4 8 so 32. No, just you will get that answer. It's 32 kgs. This is the correct answer. Okay, next. If the support cable breaks, okay, this support is there, this cable is there. The support cable going to break. When this going to break, what will happen? It will be fall freely. It will be acting like a freely falling body. For freely falling body, children, the apparent weight will be is equals to its true weight. Understood children? For freely falling body, what will happen? In the weighing machine, it does not show anything because the man will feel weightlessness. Normal reaction or weight, apparent weight must be both are 0 only. So that he will feel weightlessness or it is answer is 0 for a freely falling body condition. I hope these questions are clear to you children. Yeah, last in this concept, matrix means a mass of a man is M, standing on a weighing machine placed in a lift. If the two forces acting on the man, one is weight WMG downward and normal reaction upwards. What is that? We learned the theory, no? Same thing they given. One lift is there, inside a man is standing on the weighing machine, his weight is acting in the downward direction and the normal reaction because of this contact surface acting in upward direction. This is what they given. When the lift is at rest position, children, when a lift is not moving, when it is at rest position, normal reaction will be equals to weight of the body. When the lift is moving upward direction, what happened? The normal reaction going to increases because why children, you know formula, M into G plus A will come. Acceleration going to add. That time when it is going upward direction. So it will be normal reaction greater than weight of the body, then only body will move upwards, right? If N is pulling upward, MT is pulling down. When it is moving upward means matlab what children? GVN will be more. When the lift is moving downward direction with an acceleration, then N will be less. So you know formula M into G minus of A we are going to take, right? So that if minus will do in the some quantity, it will be less than. Then only if weight is more, then the body will come down. Okay? Downward means weight will be more, it is upward means normal reaction will be more. So remember that. Okay? Next, when the lift is falling freely, normal reaction will be 0. So directly they given correct answers only. So answer is for 10th A, 11th B, 10th, 12th C, 13th one is 0. Okay children, I hope this is clear to everyone. Okay children, thanks for watching. Next class we're going to discuss regarding frictional forces. Okay, very interesting topic, and definitely one question might be asked from friction, types of the friction, problems on the friction we're going to discuss under NLM. Thanks for watching. Bye children.